Hi everyone, Professor Christina Sover from Cal State Long Beach speaking here, and in this video we're going to be talking about the different qualitative graphs from Module 2 and Chapter 14 in our textbook. As you can see in this example, it's from Chapter 14, Section 3, Learning Exercise 3. The graph at the right is a distance time graph for our cartoon objects trip. When we read this sentence, the first thing that comes to mind is that it's a distance time graph. That means that the output is the distance value and the input is the time value for this graph. And so as time progresses, we know how far we are from the initial point. The next part that's pretty important here is the talk about cartoon object trip. When they say cartoon objects trip, what they mean is that you can instantly switch how fast or slow or where you are located at. Um, and that's just what it means for that. Now, we're going to graph the speed at which the object is traveling over time. So important for us is we want speed over time. So when we say speed over time, what we mean is to find the speed time graph. Now, speed you can think of as like when you're in your car, the speed of your car, how fast your car is going, miles per hour. Maybe you're going, in a residential area and you're being really cautious and you're going 10 miles an hour because, it's really dark and you don't want to have any incidents. Or maybe you are on the freeway in a less populated county and you're able to go like 85 miles per hour. Well, that's what we have in this example here. We have that you started at your initial point right here at the origin, that's 0, 0. Time is 0, distance from your starting point is 0. And then you traveled some distance away, and let's just call this right here, I don't know, 5 seconds. We'll have this be in seconds. And you got to this point here. If that's 5, if we're trying to maintain the same space, maybe that's 10 feet away. And then you travel along the way and you end up right about here. Notice your distance, you're still farther away than you were originally, maybe at 15 feet away. And the time looks about 10 seconds away. I'm just estimating, putting numbers here. Numbers are not required at all. I am just putting them for convenience sake so I can think about what's going on here. And in this last spot here, where I just had it in like that salmony pink color, my distance remains the same as time progresses. So I got to the point and stopped. If you want to think about this in context, maybe we can think about, let's say I'm the star and I walked towards my car pretty quickly. I was trying to get to my car really fast, and then I had to go to the other side of the car, walked around the car a little slowly, and then I sat in my car and I was just sitting in my car getting ready to drive away. So as I traveled this path, that's what happened. I started walking again from the origin. I walked very quickly to my car from my house. Once I got to my car, I needed to walk around the car. I went pretty slow around the car for reasons, I don't know why. And then once I got to the car, I was in the car and I just stopped moving. I just stayed at that distance away in my car. Let's just say that's what happened. Well, in my story, I was just saying because this first part where I'm moving the star now was much more steeper than the second part here, I was walking really fast. So let me get a different color. We can notate this part right here. I was walking really fast. And it was consistently the same kind of fast towards that distance. Then, once I Got to the car, walked slowly around it. I was like walking around the car, just slowly walking around the car. And again, this really fast and slowly business here only relates to this precise example. In another context, it might be that the pink is fast and the green is really, really fast, or they're both slow. It's in this context, that's what we're going to call it. And then in the salmon space here that I already have highlighted, I was already in the car. Well, if I'm already in my car, I'm not moving. With no movement, how fast am I going? I'm going 0. So my speed for the salmon part should be 0, and in this case, it's feet per second because we labeled time seconds and the output distance in feet. Um, then when we're looking at slowly, I know I put values here. We could calculate out the slope, do the outputs over the inputs, subtracting them apart. And in this case, it would be 15 minus 10 over 10 minus 5, and we would get 5 over 5 equals 1. So 1 foot per second with these numbers that I made up. So I was slowly walking around at 1 foot per second. And then when I was going really fast and green around my car to get there from my house, I started at my house at 0, 0, and I walked in 5 seconds to my car 10 feet away before I walked around it. So if we wanted to calculate based on the numbers I put, we would do 10 minus 0 over 5 minus 0 equals 10 over 5. That simplifies to be 2 feet per second, which makes sense that we got 2. 2 is bigger than 1, so the slope should be bigger in this green situation where we started walking really fast towards the car. We can go over when we talk about how to find slope for way later modules at the end of the semester. But if you wanted to put numbers to this and how to figure out what those precise values would be with our made up values, that's what they would be. But we can get by with just the phrase really fast and slowly. We want to make a speed time graph. So I am just going to, on the side here in black, draw a grid, a little makeshift grid. My input is still going to be time, as we see over here in purple. Find this speed time graph. So this is going to be time in seconds. And then the output is going to be our speed. And that was going to be feet per second. And let's actually color coordinate based on that green, pink, and salmon color that we already have started. In our first bit of length, say about right here, we were going the fastest possible of all of our 3 chunks, the green, the pink, and the salmon. So fast as possible, and it was consistently the same increase in that chunk. We're going to just draw a horizontal line to the green line, and we'll call that 2 feet per second. Doesn't really matter, just our walking fast. It doesn't need labels at all. If you want to, feel free to. I'm not going to because I made up the numbers. They're not real to the problem. Next, in our pink section, which was about the same amount of time, another 5 seconds to maybe right about there, we're walking slowly, consistently 1 foot per second to get around the car. Again, made up numbers. But slowly means less fast. We weren't staying still, so it shouldn't be on the axis, the time axis. It should be a little bit higher. And I'm going to put it right about there. That looks about half the speed of the green section. I'm just drawing this dash line to make sure it lines up. And these are horizontal because it was consistently the same amount of speed in those chunks. And like I just said for the salmon portion, I'm not moving at all. And if I'm not moving, that would be on the axis 0. In the time remaining, I did not move at all. So it just ends up on the horizontal axis to represent 0 feet per second. So that's how we go from our distance time graph in blue. Let me erase what we have here so we can see a little bit better. So we started off with this blue graph here. Give me one moment to erase it, I apologize. And the chunks that line up, we had the green chunk where we made up that we were walking fast from our house to our car, let's say. And so it was consistently the same fast here in the green section on the speed time graph. Then we were walking around our car kind of slow in the middle pink section, a little bit less fast in the pink speed time graph portion. And then once we got into our car, we just sat in our car for some length of time. And that's why the salmon was on the horizontal axis, because if we just sat still, we're not changing our distance at all. Our speed is at 0. If you have any questions at all, please ask as soon as I can help. Let me know as soon as I'm available, I will get to you. Thank you so much for watching, and I can't wait to see you in class. Bye.